Alrighty, folks, so we are moving on to trig ratios. Hopefully you did the introduction, kind of gave you a starting glance at them, just a glance. Trig ratios come from the fact that if the right triangle has the same angle measures, they're all similar no matter how big or small they are. If they're similar, that means they're proportional, which means the ratios between the sides are going to be the same no matter if it's a tiny triangle or a really big triangle. So in order to be able to talk about different ratios, we need to be able to look at the sides of the triangle based on the acute angle that we're looking at, because every right triangle has two different acute angles. So we're always talking about an acute angle when we talk about these trig functions. So example 1 is just trying to identify the different sides of the triangle based on which angle you're looking at. Okay, so first up, just the hypotenuse. So given this triangle PQS, and sorry, change that to an S, little typo. Q is the right angle, so that has to be the right angle. So the hypotenuse, well, there is only one hypotenuse, so it's segment PS. Now, when we're talking about the legs, we have opposite legs and we have adjacent legs, but these change depending on which side or which angle you're looking at. So when I'm looking at angle P, if I go straight across, segment QS is the opposite leg. If I'm looking at angle S and I go straight across, then side PQ is the opposite leg. Adjacent legs are the legs that help create the angle. So if I'm looking at angle P, then leg PQ is called the adjacent leg. If I'm looking at angle S, then side QS is called the adjacent leg. Okay, so every acute angle has an opposite leg and an adjacent leg. We're always talking about the legs. So SOHCAHTOA is what we tried to start introducing last week. Sine, cosine, and tangent are the names of our three trig functions. And all they are the ratios between the sides of the right triangle. So sine stands for opposite over hypotenuse. Remember, opposite means the opposite leg over the hypotenuse. Cosine stands for adjacent over hypotenuse. So that's the adjacent leg over the hypotenuse. And tangent is opposite over adjacent. So that's the opposite leg over the adjacent leg. Okay, so let's see if we can use these a little bit. So example 2, find the indicated trig ratios. So we're going to find those three ratios. Theta is a Greek letter. It's just a variable. It's like saying X or Y, but for some reason someone somewhere decided Greek letters are what we usually use to name angles. Not always, but sometimes. All right, so to find all of our trig ratios, we need all three sides. Well, here's theta. So looking at theta, that's the opposite leg, that's the adjacent leg. We still need the hypotenuse. So I just did Pythagorean theorem to find out the hypotenuse is 10. So sine is opposite over hypotenuse. So 6 over 8 equals 3/5. Cosine is adjacent over hypotenuse. So 8 over 10, which reduces to 4/5. Tangent, opposite over adjacent. So opposite is 6, adjacent is 8. 6 over 8, which reduces to 3/4. All right, so example 3 is the same exact type of problem. So this time, I have the opposite leg, I have the hypotenuse. What I'm missing is the adjacent leg. So I'm going to do Pythagorean theorem to find the adjacent leg. 2 root 5 squared. 2 squared is 4. Root 5 squared is 5. 4 times 5 is 20. So that's where the 20 came from. So a squared equals 16 and a equals 4. So the adjacent leg now has a length of 4. So again, sine is opposite over hypotenuse. So opposite over hypotenuse. So 2 root 5 over 6, which reduces to root 5 over 3. Cosine, adjacent over hypotenuse. So 4 over 6, which reduces to 2/3. Tangent is opposite over adjacent. So 2 root 5 over 4, which reduces to root 5 over 2. All right, so hopefully that's making sense. The hardest part is making sure you figure out which is the opposite leg versus the adjacent leg versus the hypotenuse. So you always go to the angle. If you go straight out from the angle, you hit the opposite leg. The other leg is the adjacent leg, and then hopefully you recognize the hypotenuse, which is always across from the right angle and is always the longest side of the triangle. All right, so example 4 and 5 are same idea, except that we're given one of the trig functions and we have to find the other two, which means we have to draw the picture ourselves. So first thing you do is you just draw a right triangle and label one of the angles theta. It doesn't matter which one is theta, but you have to label it because then sine, remember, is opposite over hypotenuse. So from theta, opposite is 7, hypotenuse is 10. I then can use Pythagorean theorem to find the missing leg, which is going to be the square root of 51. So A is the square root of 51. Cosine, adjacent over hypotenuse, square root of 51 over 10. Tangent, opposite over adjacent, so 7 over root 51. And just leave these as root 51, unless it's a perfect square. Like here, the square root of 100 is exactly 10. But if it's not a perfect square, just leave it. We're not worrying about reducing those right now. All right, so example 5. This time I have tangent. So I drew my right triangle, and this ended up being the longer side, so I just put my theta here. It doesn't matter. We could have put theta here. The key is opposite leg over adjacent leg. So from theta, opposite is 8, adjacent is 3. So I use Pythagorean theorem to find the hypotenuse is the square root of 73. So that's my hypotenuse. So sine, opposite over hypotenuse, 8 over root 73. Cosine, adjacent over hypotenuse, 3 over root 73. And that finishes our introduction to trig ratios. We're going to be doing a lot more with them, so this is the basic introduction to what a trig ratio is. I'll see you soon. Bye.